In the last video, we talked about making graphs of functions. We graphed this linear function and we graphed this quadratic function. In this video, I want to talk about root finding and talk about how root finding is useful when it comes to graphing functions. Okay, so the first thing is, what is a root? And what I want to just say here, imagine you have a tree. So this is a tree, and then this here is the trunk of the tree, okay? And then this is the ground, okay? And then when the trunk of the tree touches the ground, this is like where the roots sort of begin. Okay, so when it comes to our case here, we can have a function like this. Okay, and when this function here, when it touches the ground, now what's our ground? Our ground is when f of x is equal to 0, right? So we start on imagine f of x is like height. Okay, so this is going up, right? This is positive height, then going down, that's going underneath the ground, right? So if we say f of x is equal to 0, we just move up and down this axis until we're at this 0, until we're at this 0 height here, and that means that we're on the x-axis. And now when we find the 2 points, right, that correspond to f of x is equal to 0. So, in the previous videos we were saying, well, x is equal to 1, that means that, the f of x is equal to 2. But similarly, f of x is equal to 2, we can go back to this 1, we could also go over here to this 4. So by saying f of x is equal to 0, well, we have two answers for x. We can say, well, when x is equal to 2, f of x is 0. When x is equal to 3, f of x is equal to 0, right? Now these two values, x is equal to 2 and x is equal to 3, these are the roots of f of x, okay? These are the roots of f of x, okay? And we'll see now that the roots of f of x are very useful when it comes to plotting functions. Okay, so let's first of all talk about, let's take the linear function that we had before. That was this one here, 2x plus 3, and let's plot it again, but this time finding the roots. So f of x is equal to 2x plus 3. Okay, now let's sort of draw it to begin with. Okay, so we had that point there, right? So we go back and look at it again. We had that point there, which was 3, 0, okay, that point there. And we have another point. We can imagine another point back here where it crosses the axis, okay? Now, incidentally, in order to plot this, we just needed 2 points, right? Because in order to plot the line, we just needed 2 points. We just needed this one point and this other point over here. And then we had them, we could actually just join a line between them and then just extend that line on in either direction, right? So in order to plot this linear function, we just need 2 points. So why not pick 2 very convenient points? So we could pick the point where the line crosses the f of x axis, and we could pick the other point where the line crosses the x axis. Okay, so we can pick the 2 points where it crosses the axis. Ends up being the easiest 2 points to pick. Okay, so f of x is equal to 2x plus 3. Okay, so how do we get this point here where it crosses the axis? Well, that happens when x is equal to 0. So here's the x-axis, okay? We go along the x-axis until we reach a 0, and then that will happen, okay? So we'll find this point where it crosses the x-axis, or the f of x-axis, sorry, when x is equal to 0. Okay, when x is equal to 0, well, that's f of 0 is equal to 2 times 0 plus a 3. Okay, 2 times 0, that's equal to a 0, plus a 3, that's equal to 3. Okay, and then we get out the point 0, 3. Okay, now if you've already done some coordinate geometry, then you'll recognize the equation of a line formula. And in the equation of a line formula, you have this number which doesn't have an x in front of it, and this is called the y-intercept. Okay, and you can see that number in our function over here. It's just the one that doesn't have the x in it. It's just the one that doesn't have the x in it. Okay, you can see this is 2x plus 3. So the number which doesn't have the x in it, that's going to be the y-intercept. And when you put the 0 in, you see that will just go, right? That 2 times 0 will just be left with the number. So that's always called the y-intercept 0, 3. So that one there. But no worries if you haven't seen that. It's good to always sort of to kind of connect ideas in math. So if you've seen one thing in one place and you see it again somewhere else, it's a good idea to understand that they're connected, because then you have less to remember. You don't have to remember the same thing twice. Okay, so that's the first point. The second point has to be when the axis crosses the when the line crosses the x-axis. And the line crosses the x-axis when f of x, so this is the f of x axis here, when f of x is equal to 0. Okay? And we should also use these implies signs. So if f of x is equal to 0, this means that implies, so then I'm allowed to write the next thing. Okay, so f of x is equal to 0, that's when we're on the ground, and that's when we can find the root. Okay, so f of x is equal to 0. Right, this is what f of x is equal to. This is f of x here, okay? Okay, now, f of x equal to 0 means that this thing here, this 2x plus 3 is equal to 0. So 2x implies, if f of x is equal to 0, that implies 2x plus 3 is equal to 0, okay? Now remember, in an equation, okay, well first of all, what we're looking out for this is, what we're looking for with this is we want to say what the x value of this is going to be. We want to write down the point. We already know that the output's going to be 0. We already know that we're 0 for the f of x value, for the output, right? Because we decided that. We don't know what the x value, so we're looking for the x value. We have this expression here, this equation here, and we want to get down to a point where we can say x is equal to something. So in other words, we want x on its own on one side of this equation, okay? So right now we have this 2 and this 3, which is stopping us from having the x on its own on one side. So we want to move them, and we want to move them to the other side. Okay, so okay, so this is an equation, yeah? And in an equation, you're allowed to do whatever you want to the equation once you do it to both sides. So you can add something to both sides and you don't change the balance, or you can take something from both sides and you don't change it, or you can multiply something on both sides and you don't change the balance. So as long as you do the same thing to both sides, you don't change the balance. So what we want here is we want to end up with x equals something, x on its own on the left-hand side. The 2 and the 3 are stopping us from having the x on its own on one side. So the question is, what are the 2 and the 3 doing? So we can see here that the 3 is adding, okay, and the 2 is, so in order to get rid of the 3, we'd have to subtract a 3. And remember, in an equation, we have to subtract that 3 from both sides, okay? Now we have a 3 minus a 3 on the left-hand side, so they just cancel out, okay? So we have implies, I always forget my implies sign, 2x is equal to minus 3, okay? So x now, so this time, 2x is equal to minus 3. We want to get rid of this 2. So this 2 is multiplying, so what we need to do is divide both sides by that 2, and then they cancel, and we end up with having x is equal to minus 3 over 2. So x is equal to minus 3 over 2 is the root. That's the root. Okay, x is equal to minus 3 over 2. Now, this can be done actually in shorthand. You don't have to take so many lines to do this. What I can do, and I'll just do it in a different color over here just so you can see. If I was given this 2x plus 3 equal to 0, I can do this shorthand. I can say, okay, anything that's added on one side is subtracted on the other side. Now I want to get rid of this 3 to the other side, so this is now 2x is equal to minus 3. Okay? Now anything that's multiplied on one side is divided on the other. So what's added on one side is subtracted on the other. What's subtracted on one side is added on the other. What's multiplied on one side is divided on the other, and what's divided on one side is multiplied on the other. So this 2 is multiplied on the left-hand side, which means that it's divided on the right-hand side. You get very quick with these after a little while, and you can just look at this and immediately know x is equal to minus 3 over 2 is going to be your answer. Okay, now that we have those 2 points, we're able to connect those two, and we have our plot. And we made our plot just using the roots. Now there wasn't really an obvious advantage exactly. I mean, it just sort of makes sense to pick the points that happen to be on the axes. It's sort of a rule of thumb, seems to make sense. But here we can't really see too much of an advantage of finding the root in order to plot this. But for so it's not clear what the advantage is. However, for the quadratic equation that we did before, the advantage will be a lot more clear. So this was the quadratic that we used before, and what I want to do is find the roots of this quadratic equation and then use that to plot it. Okay. So let's write it again. So f of x was equal to x squared minus 5x and plus 6. So this is my quadratic equation. And okay, so we know that, so let's go ahead and plot it. So let's say these are the two roots right there and there, okay? I don't know what they are. X equals, I don't know what it is, and x equal will be the two roots, okay? Now, I know that these quadratic equations, right? These quadratic equations are either U-shaped if you have like a plus x squared, right? And they're n-shaped like this if you have a minus x squared, right? So just looking at this from the beginning, I'm like, okay, this is a quadratic function because of the x squared, so it's either U-shaped or n-shaped. This is a plus number for the x squared, so that's a U-shape. And then what I realize is if I had those two roots, you see, then I would, I'm able to basically, can imagine what it's going to look like, right? Now, if we go back to the example that we had before, when we did this example here, see, when we got the 0, 1, and 2, we got the 0, 1, and 2. And these were the first 3 points that we got. Now, we could see that these 3 points, that they weren't collinear, so they weren't in a straight line. So we knew we were going to be fitting a curve. But we didn't know exactly, would this curve kind of keep on going down, or would it loop around and come back up, okay? So the point is that if we were only going to have 2 points, if we were only going to figure out 2 points on this list here and try to draw, the graph from that, the roots would be the best 2 points because they're sort of either side of this symmetric thing here, right? We know that it's going to be U-shaped, and we know that it's going to be symmetric either side of this middle point here. Okay, so the roots are the best ones to pick. If we were only going to do 2 points, the roots would be the best one. So that's why with a quadratic equation, it makes sense to find the roots more than anything else. Okay, so how do we find the roots? So this is, remember, this is the f of x axis. And what we want to do again is say f of x is equal to 0, right? And then that's when we're on the ground, there's f of x equal to 0. And then we go across and we'll find this point, and we'll find this point here. Okay, so for the roots we say f of x is equal to 0. Okay, if f of x is equal to 0, that means, well, f of x is equal to, this is our function, right? F of x is equal to 0, so that means that x squared minus 5x plus 6 is equal to 0. Okay. Now, what you should know already is about factorizing these quadratic expressions. I'll do another video about factorizing quadratic expressions somewhere else. But we know after we factorize this that we'll end up with a set of brackets multiplied by a set of brackets. Okay, so what we have to put in here is like an x plus something, or an x minus something, and an x plus something, and an x minus something into the other set of brackets. Okay, so we need to put a number here and here that will multiply to give us x squared. That first one's always easy, it's always x and x, okay? Okay, now we have to put a number here and a number here that multiply to give us 6. So let's try. So 1 multiplied by 6 is equal to 6. Okay, so that could work, a 1 and a 6. Now the number that we put here and here, it doesn't only have to multiply to give us a 6, it also has to add to give us a minus 5. It has to add to give us, so we need these 2 different conditions. We need to satisfy these 2 different conditions. So the numbers have to multiply to give us a 6, but they have to add now to give us a minus 5, and 1 plus 6 gives us a 7, not a minus 5, so that one doesn't work. So let's try 2 times 3, and that's equal to 6, right? So that's looking good. 2 plus a 3, that's equal to a plus 5, right? But not a minus 5, so that one goes off the list. So what can we choose? Well, actually what we choose is minus 2 times minus 3, right? Because we know that a minus by a minus equals a plus. We also know that a plus by a plus equals a plus. And we know that a minus by a plus equals a minus, and we know that a plus by a minus equals a minus. A minus by a minus is kind of like a double negative, like if you said it's like not raining, right? So it's like a double negative. So minus by minus equals a plus. And that means that, well, a minus 2 and a minus 3, that's equal to a minus 5. Now, sometimes people have difficulty adding minus numbers, and what I do for that is I just think about the surface of the water, okay? And I want you to think is pluses mean going up in the air, and minus meaning going down underneath the water, right? So if you have a minus 2, that's down 2, and a minus 3, that's a minus 5. If you had a minus 2 and then a plus 3, that would be up just 1, right? If you had a plus 3 and a a plus 3 and a minus 2, that would be plus 1 overall, right? So that kind of, you always need to keep an idea of a direction, up and down or left and right when you're adding plus and minus numbers, and think of them as steps in that direction. Okay, so a minus 2 plus a minus 3 is a minus 5, and we end up here with a minus 2 and a minus 3. Okay, so what I'm saying here is that that this thing, x minus 2 by x minus 3, is equal to x squared minus 5x plus 6. So instead of taking my word for it, I want to, let's just do a quick aside just to show that this is true. So we take x minus 2 and x minus 3, okay? So we go ahead and we multiply out these brackets. So it's an x times an x, and it's an x times a minus 3. And that gives us, well, x times x is x squared, and x times minus 3 is minus 3x. Okay, that's the first one. Now the minus 2 times the x and minus 2 times the minus 3. So that gives us, well, minus 2 times the x is minus 2x. Minus 2 times a minus 3 is a plus 6. Okay, and then we see this is why we're adding those two numbers to get the minus 5. We have an x squared, and then minus 3x and a minus 2x, that's minus 3x's, and a minus 2x's is minus 5x's, okay? And then that's a plus 6. So that's the end of our side. Just put it in some sort of green box so that we know that it's an aside. Okay, so we've shown that this, actually, if you multiply it back out again, you would get the same thing back out again. Okay, so this here, this is true. This is indeed the same thing. Okay, so now we have x minus 2 by x minus 3 equal to 0. Okay, and now we have to find out, we have to end up with an x equals something and an x equals something, right? We have to get these two values of x out from this expression. Okay, so here's something. If I have a 2 times a 0, I get a 0. If I have a 0 times a 2, I get a 0. The only way to get a 0 out of a multiplication is if one of the numbers is already a 0. Okay? So, and also in mathematics, when we put brackets around something, we really think of that thing inside the brackets. It's like a box. And we just think about it as one number, right? If you put brackets around something, you just think about it as like one number. So this here is a number, and it's multiplied by another number, and you get 0. So that means one of them has to be a 0. So either the first one, x minus 2 equals a 0, put the brackets if we want it, or x minus 3 is equal to a 0. Now if x minus 2 was equal to a 0, well then this minus 2, this is subtracted on the left hand side, so it's added on the right hand side, so x is equal to 2, and then this minus 3, this is subtracted on the left hand side, so it's added on the right hand side, so x is equal to 3, and these are the roots. Okay, x is equal to 2 and x is equal to 3. Okay, so we know that these are the roots, and we know that these roots are either side of this symmetry line, right, this mirror that goes right up the middle. So now what we do is, if we wanted to get more points, we would go back to 1 and we would go forward to 4, we would get those two. Then we would go back to 0 and we would go forward to 5 and we would get those two. And we can keep going in pairs and pairs because of this symmetry thing here. But we needed to know in the first place where this sort of symmetry line was, and it happened to be in between the, the 2 and the 3 are sort of exactly spaced around it. So that's why it's useful to get, the roots when we want to plot things. And there's a lot in mathematics which is about root finding. Okay, so that's all I want to talk about for now about finding roots. In the next video, I'm going to talk about applications. So talk about some real world applications of functions, or not exactly applications, but just sort of like we'll think about them with kind of a real example where x is something in the real world and f of x is something in the real world. Okay, so until